Hello everybody, welcome to another Mammoth Site video. Today we're going to be kind of kicking off a series we're calling Science with Seth, where basically we can look at some chemical reactions, some different science experiments that we can do that kind of talk about some of the basics of science, how we use it here at the site, and how it's used in a broader context in a variety of sciences. So today we're going to kind of focus in chemistry with probably one of the most famous reactions you can do, one of the most simplest reactions you can do, which is an acid-base reaction, in particular focusing on baking soda and vinegar. So when we have our baking soda and our vinegar, our baking soda in our volcano is our base, and our vinegar is our acid. And when we mix those together, you see a foam forms, you hear all these bubbles kind of starting to form, and you see all of this material starting to flow down the side. You know, as you've seen with our vinegar baking soda reaction, vinegar and baking soda are things we commonly find in our households. They're generally considered to be pretty safe to use. I'm wearing lab goggles right now just because when we're working with different types of chemicals, when we're not sure how they might interact, it's always good to wear some kind of personal protective equipment, whether that's goggles to make sure stuff that doesn't get splashed in your eyes, whether that's gloves if it's something that could be potentially damaging to your skin, whether that's using the right to make sure there's right kinds of ventilation. The most important thing when you're doing chemical reactions and doing science like this is to make sure that you know how your chemicals are going to interact, and if you don't, if you don't know how they're going to interact, make sure that you're using them in a safe manner with your protective equipment. So this acid-base reaction, this baking soda and this vinegar reaction, it makes three things. It makes water, CO2, a gas, as we already talked about, and also it makes something called a salt. Now, it's not a table salt, although table salt is a form of salt, but there are a variety of different what we call chemical salts. So this might look like salt, but it's not something you can eat. Now, one of the ways we know that this is making a gas is when we mix them together in a pressurized environment. So when we put it in a place where there's only so much space for the gas to go. So I'm going to do this quickly. So I'm going to add. And you can see it built up all that pressure and then fell down, and basically, eventually it exceeded the amount that cap could contain, and it burst out of its container. So while baking soda and vinegar are one example of an acid-base reaction, we actually can see that there's a lot of different acids and bases that we find throughout our environment with the different elements and as different elements kind of interact in nature. One of the ways in geology that we use acid-base reactions is when we're identifying different types of rocks and minerals. So if we look here, I've got two samples of a mineral where if you look at them, there are some differences in their shape, but their color is the same, and they're both kind of this semi-transparent crystal. And so one of the ways we can kind of figure out exactly which two we're looking at is by applying a different type of acid called hydrochloric acid to our samples. Now, hydrochloric acid reacts with the carbonates in a mineral called calcite, which is CaCO3. And so when this hydrochloric acid makes contact with it, much like you saw with the vinegar and baking soda reaction, it'll kind of bubble. We call this effervescence. Basically, it's producing that CO2. It's producing those gases. And so one of the things we can do is I can add a little bit of HCl to our calcite, and it bubbles a little bit. But when I add it to our other sample, a quartz mineral, it doesn't bubble at all. So one of the neat things with this calcite, with this calcium carbonate, this CaCO3, is we can see it in our minerals. We can also see different types of organisms use it. This right here is a piece of coral that uses CaCO3, or that calcium carbonate, in its structure and in its skeleton. And when I add a little bit of HCl to it, it itself will bubble. And so that tells us that we've got carbonates in here. Now, we can also then use this as well to see when we look at different types of rock. I've got a sample of rock right here. Now, rocks are made up of minerals, but they're not necessarily made of just one mineral. They're oftentimes made up of little tiny pieces of a bunch of different minerals, especially sedimentary rocks, which are made from basically pieces of other rocks that have broken down. So one of the things we can try to do is figure out what types of minerals are in our rock samples. And one of the ways we can do that is by applying this hydrochloric acid to it. So we can apply it in different spots on our rock and see where there's some spots where it bubbles a lot and some spots where it doesn't bubble at all. And we can use that to figure out where the calcite inclusions are at, where we've got bits and pieces of calcite, where calcite's maybe making up the cement that's holding the rock together, and we can kind of see that as well. Now, we talked a little bit about coral using a base in its structure, but we can also see that we as humans can use bases and acids to help to help us with a variety of different things. Some of the foods we eat use acids to kind of give it that tangy flavor. A great example is citruses. So that kind of that sharp, that tart flavor that you get from eating lemons, limes, and oranges is actually from an acid that's present in there. We can also use bases if our stomachs are feeling upset. One of the really cool things is we can use, basically if we look at a lot of antacid tablets, they're basically just made of calcium carbonate, that calcite material, and we can apply that, and they react with the acids in our stomach and helps kind of neutralize our stomach a little bit. It helps it make sure that we aren't feeling quite as, when you have an upset stomach or you have acid reflux, we can use these little tablets of calcium carbonate to kind of demonstrate and basically neutralize our stomach acids. And I can show you that with this right here. If I add a little bit of hydrochloric acid to this tablet, you can see it itself is bubbling and making that carbon dioxide as it reacts. Now, one of the other ways we use calcium carbonate in our daily lives, especially if you ever like to play outside during the summer and use sidewalk chalk, a lot of chalks are also made out of calcium carbonate. They're actually made out of little tiny microorganisms that used to live in our oceans. And so when we find layers and layers of limestone that are made out of that, we can basically take that calcite and use that chalk to draw and use it for writing as well, because it breaks apart very, very easily. So we see acid-base interactions all across the world, all throughout nature, all throughout processes that humans use. And it's one of those things that is just a fundamental part of our understanding of chemistry and how different substances interact. So with that, I want to thank you guys for tuning in. And if there's certain chemical interactions or certain scientific experiments you'd like to see us do in the future, leave a comment on this video below, and we'll see you next time.